Welcome to Master Mathematics in Minutes. Today's topic is about deriving the geometric series formula, and we will conclude the topic with a summary. And finally, be kind and subscribe for more videos. So, what is a geometric series? The sum of the numbers in a geometric progression is called a geometric series. We've defined what a geometric progression is in the previous video. So with the first term as a, the second term as a times r, the third term as a times r squared, and the final term as a times r to the power of n minus 1. And we'll add these terms together. And we'll denote that as Sn because we're summing across a total number of n terms. And that is called a geometric series. And we'll label that as equation 1. And we'll define equation 2 as equals to equation 1 multiplied by r, which is the common ratio. So on the left-hand side with r times Sn, and on the right-hand side with a times r becomes ar times r becomes ar squared, and the final term, a times r to the power of n minus 1 becomes a times r to the power of n. And the second step is to subtract equation 2 from equation 1. So, on the left-hand side, we have Sn from equation 1, copy that down, and because we're subtracting equation 2 with minus r times Sn, and that is that term here, minus r times Sn. So that is the left-hand side. And on the right-hand side, with a, which is that term a, copied down, and all of the intermediate terms will cancel. With ar minus ar, that is 0, ar squared minus ar squared, that is 0, and so on. And we're left with the final term, which is minus, because we're subtracting here, a times r to the power of n. And so that gives us the right-hand side. And so we'll factorize Sn out, and that becomes Sn into 1 minus r. And on the right-hand side, we'll factorize a out, and that becomes a times 1 minus r to the power of n. And we'll solve for Sn, that becomes a into 1 minus r to the power of n divided by 1 minus r. And r cannot be equals to 1. So, that is the formula for the sum of the first n terms in the geometric progression. So, consider an infinite number of terms. So if we're summing across an infinite number of terms in the geometric progression, what is the formula that we can use? So this slide is where we'll derive that formula. So if you're summing across an infinite number of terms, and if the common ratio, the absolute value of the common ratio, is strictly less than 1, we have the common ratio raised to the power of n. Remember, n is a really big number. That entire thing tends to 0. So say, for example, if r is 0.1, which is less than 1, that is true, r squared, for example, is 0.01, so it gets closer to 0. And r to the power of 3 is 0.1 cubed, and that is 0.001, which is even closer to 0. And so if you were to stretch that to infinity, that converges to 0. So what we have here is we've stated the formula from what we have from before. With Sn is equals to a into 1 minus r to the power of n divided by 1 minus r. And that Rn tends to 0 as n tends to infinity. So we could replace Rn as 0. And n is now infinity because we're summing across an infinite number of terms, and all of the other terms remain the same from the prior equation. And simplifying that, we have s infinity is equals to a divided by 1 minus r, provided that the absolute value of r is below 1. To summarize, a geometric series is the sum of the numbers in the geometric progression. So with the first term a, second term ar, third term AR squared, and so on. And by summing each of these terms together, we have Sn, which is the geometric series. And we've derived two formulas for Sn. The first one is Sn is equals A into 1 minus r to the power of n divided by 1 minus r, and r cannot be equal to 1. And if we're summing across an infinite number of terms, with S infinity is equals A divided by 1 minus r, provided that the absolute value of r is below 1. Thank you very much for watching. This is Master Mathematics in Minutes.